Hi, everybody. This is your more or less your pre-lab lecture for your lab this upcoming week. And what you're going to be doing this week in lab is you're going to be working with a mechanical pipetteman. You may or may not have used a mechanical pipetteman before. We will be using mechanical pipettemans like this in lab virtually every single week. And I just wanted to give you a little bit of a rundown of how they are used. So what I have are three of the pretty standard sized pipettemen. This right here has 20 on the side. This is referred to commonly as a P20. We have P20s. We also have P10s. This is a pipetteman that is very accurate if you're trying to collect 2 to 20 microliters of a solution. If you want to collect more or less than that, the accuracy of this instrument is going to go way down. Same thing for a P10. A P10 has a range from 2 microliters to 10 microliters. If you try to collect more than 10 microliters, it's going to run into a little bit of a problem. The way that this instrument is adjusted, as you read here, is 20.00. So that's 20.00 microliters. You'll see that there's this yellow cap. Then there's this kind of gridded piece of plastic, and you can adjust this, turning it clockwise or counterclockwise to a new volume. So I've adjusted this down to 18.60 microliters. So that yellow line in the middle, kind of think about that as your decimal point. So 18.60 microliters. Now, the way to use this pipetteman is, if you'll notice, I've got it held like such. I have my thumb on this plunger or this depressor or this plunger. I'm going to press down. And what I'll notice is that that's basically the resistance. That's the highest level of resistance that I'm going to encounter. And what I want to do is, if I'm collecting a solution, I want to gently and slowly press down, put the tipped pipetteman into a solution, and then very slowly and gradually release. I would argue that the rate that you press down, go with a 1, 2, and then release, 1, 2. What you do not want to do is this. Because what happens is the solution at the end of the pipette tip gets sucked up into this barrel here, which is going to contaminate any and every solution that you use after this. In addition to that, it's going to damage the interior, the inner workings of this pipetteman, because you have a series of springs in here that you'll work with. You'll press down, and so that's what you'll be doing with this piece of instrumentation. Now, the next pipetteman is a P200. This is a 200 microliter pipetteman. So this is good for anywhere from 20 to 200 microliters. Again, you have a plunger, you have this gridded piece of plastic, you read out 100.0. So could you could you collect a solution down to the hundredths position or the thousandth position? No, you can't. But you'll turn this clockwise or counterclockwise. For instance, here we've got 108.4 milliliters. Same thing, depress, slowly release. Now, what I want to continue on with is, if you're going to eject a solution from this pipetteman, so let's imagine that I have a tip on here and there's a solution within that tip, and I want to go ahead and eject that solution into a new microcentrifuge tube. What I'm going to do is I'm going to depress and then press even further all the way. That's when I'm ejecting, not when I'm collecting, only when I'm ejecting. So first resistance for collect, release. First resistance, second resistance to eject a solution. Okay, your last pipetteman is this right here. This is known as a P1000. This has a volume, or this will successfully collect a volume up to 1,000 microliters. So as you can see right now, it reads 500. Well, this is 500 microliters. If I adjust this upward of my 4 digits within this pipetteman, I will get ultimately to 980, 990, 999, 1,000 microliters. Now, Same thing, depress a second time for the ejection. What is important to notice is that this pipetteman, let's look at it, it goes up to 1,000. If I could get it going to 100 or 1,020 or 1,030 microliters. Whenever you do that, I was saying a moment ago that there are springs in here. Well, what's going to happen to those springs is that they're going to get stretched out. And as those springs get stretched out, the life that they have begins to decline. So what that leads to is the accuracy of this instrument going way down. So as that spring stretches out within here, well, the sort of integrity that that spring has is going to be diminished. So that's going to lead to a pipetteman that is considerably less accurate. Now, the purpose of this week's experiment is for you to use the P1000. You can use any of the other pipettemans, but it's for you to all have the opportunity to use a pipetteman. There is enough time for every single person in this class to do this experiment themselves. I want you to work in groups of 2, but I want each person to take the opportunity to work on it. So what you're going to do is you're doing 5 trials of 25% of the capacity of this. 25% of the capacity of a P1000 is 250 microliters. You're going to do 5 trials. You're going to do some calculations with that. Then what you're going to do is 50%. 5 trials, do some statistics. After that's all said and done, you're going to then work with 100% of the capacity, 5 trials, and go on from there. Now, all of these instruments, you're going to be using them over the course of the semester. This P1000, I would argue, is the one that we're going to be using the most. But be careful when you're pipetting. Remember, depress and then gradually release. One of the things that people do is they just let it go as fast as they can. We don't want to do that because that's whenever this instrument gets contaminated and is considerably less effective for future semesters and any other time using it. All right, well, thank you very much, and I hope you have a successful and constructive lab.